All right, so 5.6 deals with inequalities in two triangles. We're not going to deal with the indirect proof, so just inequalities in two triangles. Where we left off last semester were inequalities in one triangle, so now we're just going to do inequalities in two triangles.
Is it the same thing for...
Okay, so the hinge theorem states that if two sides of one triangle are congruent to two sides of another triangle and the included angle of the first is larger than the included angle of the second, then the longer third side is across from the larger included angle. So if we look at this example, yeah. So it tells us that angle A is greater than sign, the measure of angle D. So we know that angle A is bigger than angle D. So the third side across from angle A is going to be larger than the third side across from angle D, which is EF. So we see that BC is greater than EF. And this only works when we have two pairs of congruent sides. So we see that AB is congruent to DE and AC is congruent to DF, and we're talking about the included angle in both of these triangles. Next, we have the converse of the hinge theorem, which is the same thing but flipped. So if two sides of one triangle are congruent to two sides of another triangle, and the third side of the first is longer than the third side of the second, then the larger included angle is across from the longer third side. So the larger included angle is across from the longer third side. So again, here we have two pairs of congruent sides. And then we're dealing with the included angle on both of these triangles. So we know that since JK, this third side, is greater than KL, this third side, we know that the opposite angle on the triangle with the longer side is going to be greater than the opposite angle on the triangle with the smaller third side.
Wait, Ms. Carver, what's the difference between that and the hinge theorem?
So this is the converse of the hinge theorem, so it's just the flip. So the last one told us if the angle is bigger, then the side opposite of that triangle is going to be longer. This one tells us if the side is longer, then the angle opposite is going to be bigger.
Okay.
You're welcome. Okay, so now we have some examples.
So wait, how do you know which one is bigger?
It'll tell us. It'll give us either that the third side is longer or that the angle is bigger. And then we're going to have to see which triangle has the bigger. You'll see in the example. Okay? So given D is the midpoint of AC, angle 1 is less than angle 2. What can you deduce? So in order to use the hinge theorem, we need to have two pairs of congruent sides. Right now we know that AD is congruent to DC because D is the midpoint. Do we have another pair of congruent sides? BD. How do we know that BD is congruent? The reflexive property. So we also know that angle 1 is less than angle 2. So looking at side AB or BC, which one is going to be longer? Raise your hand if you think it's AB is the longer side. Raise your hand if you think it's BC. So since angle 2 is bigger, AB is going to be longer. So we could say that AB is greater than BC, or we could say BC is less than AB. If you want to keep it consistent, so we know that the measure of angle 1 is less than the measure of angle 2. What is the third side of this triangle that is opposite of angle 1? BC. We're going to keep the less than sign. What's the third side of this triangle that's opposite of angle 2? AB. So we know that BC is less than AB. Any questions on this one? Okay, another example. So complete with a less than, greater than, or equal to sign. So we're comparing angle 1 to angle 2. We know that the side opposite of angle 1 is 4. And the side opposite of angle 2 is what? 3. So is 4 greater than, less than, or equal to 3? Greater than. So is angle 1 going to be greater than, less than, or equal to angle 2? Greater than.
I just have a question on how you know it's greater than less than. I just keep getting confused.
Like the sign?
No, like, why is 4 greater than 3?
Because 4 is bigger than 3.
Oh, I thought it was, okay.
4 is talking about like this side is like 4 feet long. 4 is like the measurement. All right, example 3. Find the range of values for K. So we're looking at angle PLN, which is 5K minus 12, and angle NLM, which is 38. So what is the side length that's opposite of PLN, this angle here? 18. What's the side length that's opposite of NLM, this angle? 19. So is 18 greater than, less than, or equal to 19? Less than. So is 5K minus 12 going to be greater than, less than, or equal to 38? Less than. So now we have to solve for K. So we have 5K minus 12 is less than 38. How do we solve for K here?
Add the 12 to 38.
So we add 12 to both sides. And we get 5K is less than 50. And what do we do next? Divide 5. And we get K is less than 10. Any questions on this one? All right, let's go to example 4. So compare the measure of angle ABC and the measure of angle DEF. So we're looking at this angle here and this angle. So we have what is the side that's opposite of angle ABC?
12.
What is the side that's opposite of angle DEF?
10.
Is 12 greater than, equal to, or less than 10?
Greater than.
It's greater than. So is angle ABC going to be greater than, less than, or equal to DEF? Greater than. So angle ABC is greater than angle DEF. Okay, and last. Compare PS and QR. What is the angle that's opposite of PS? 80 degrees. And what's the angle that's opposite of QR?
100.
Is 80 degrees greater than, less than, or equal to 100 degrees?
Less than.
So is PS going to be greater than, less than, or equal to QR? Less than. So PS is less than QR. That's 5.6.